Hey guys, this is one of your homework questions. I've had several students come in and ask me questions about it, so I figured this might be a good question to work so you're aware of how to do this on the test. Alright, so I just drew this and I've already drawn nodes on here, but I'll erase them again. Alright, so if that's V1, we'll call this V0 and this is our ground, and we can call that V0 because if you look at this V0 right here, it's all the same wire and it's connected to ground. So we'll call that V0, and then we'll call this guy V1 right here. Okay, and so you can think of this as, you can work this several different ways. I'm gonna kind of work it the slower way, and I'm just going to kind of work it with three equations, three unknowns. You could do this as a 2x2 matrix, but just to not confuse anybody, I'll work it a little different. So what we can say is that I'm going to start with V0, and I'm going to sum all the voltages for V0. So we'll call this V1, we'll call this V0, we'll call this IX. Alright, so if I look at V0, I can say there's a 8K going in there, leaving, and there's a 10K leaving. So for V0, I can just write 1 over 10K plus 1 over 8K. Now, pay attention that I'm writing the K's very explicitly here, because if you don't, because there's a 4K right there, you could get messed up with that. So that's our little guy here, and we're going to invert this eventually, and I'll make my constants column. And so if you look at the constants here, there's a 7 milliamp going in, and as we know, when you do 7 milliamps going in, you flip it to the other side of the equation, it becomes, from a negative, it goes to a positive. Okay, so then if you look at everything connected to V0, there's a V1 connected to it, and that's just going to be negative 1 over 10. Okay, and in terms of IX, there's nothing for us to define there. So for the next step, we are going to sum everything for IX. So we're going to define IX. So if you look at IX, you can think of IX as being V0, this is just Ohm's law, V0 minus V1 divided by 10K is equal to IX. So if you put that kind of just in an equation that's a linear equation, then we can say that V0 is 1, V1 is negative 1, and you can say this IX is equals to 10K. Yeah? Alright, and there's no constants there. So the last thing we can say is that V1 right here, it's connected to ground through this power supply, this voltage supply right here. So what we can do is we can just say that V1 is going to be equal to the negative of 4KIX. So if you say V1 is equal to the negative of 4KIX, and if you wanted to write that as a linear equation, you'd say V1 plus 4KIX is equal to 0. So we can say V1 right here is 1, and V0 we can ignore, and then we can say this is 4K. And that's going to be 0. Now it's very important to put all these K's in here, and the milliamps in here, because these K's can kind of mess up your answer and give you the wrong answer. But if you put it in MATLAB really carefully, which I've already done, let me see if I can pull this guy up. And find the answer. So if you pull that up into MATLAB, you'll get, you'll end up with negative 16 and 24 and 4. And This is going to be in milliamps, this is going to be in volts, and this is going to be in volts. Alright, so there you have it. Be careful working this problem and make sure your units are right and you'll get the right answer. A lot of times, like for example for this one, I got a 56, and a negative 0.01 here, and that's because my units were wrong, so I had to go rework it and put the actual numbers in. So you can't kind of do a trick or a cheat and remove the K's and assume that that 7 is a milliamp. If you do that, then you have to also remove the K's from those 10 and that 4, which is what I didn't do. So sometimes it's just better to put the unit